Sure. Okay, so welcome back. Let's start with the recording. Where's my note? Hi, come on. Okay, right here. Okay, so 3.6, building and analyzing functions. I'm using the example from PowerPoint, which you guys have on Canvas, PowerPoint section 3.6. And we're going to start with the example when we have to find the distance from origin to a point on a graph. So this is the problem. Let P be a point, x comma y, be a point again on the graph y equal x squared minus 1. A. So we have a couple things. Express the distance. D from P to the origin. As a function of x. As a function of x. Okay, so let's work on A first. So we're going to build the function. That means we should only have everything written using only one variable, which is x. And we talking about the distance. You need to express the distance. So let's review the distance formula. So distance between 2 points x, x1, y1, and x2, y2 is given by d equal square root x2 minus x1 to a second power plus y2 minus y1 to a second power. So this is the distance formula when 2 points are given. Okay, so we need to create that formula. We need to create a distance. So a couple things. We have to find the distance from the origin. So we have point O, which represents origin. And we know origin has coordinates 0 and 0. So you may think about that origin is your x1 and y1 in the formula. And point P, the second point, it's point P, x comma y, which belongs to the graph y equal x squared minus 1. So P is a point on the graph y equal x squared minus 1. Okay, y equal x squared minus 1. So think about creating table of values, okay? So you have x, and to evaluate y, we have to plug an n into the equation, x squared minus 1, okay? So technically we have points x comma y. since we're building the function, so you should not have two variables for function. Okay, you have to have input and output. So we don't know exactly which specific point they want, because they not really tell you what is the x-coordinate of the point. They only tells you that that point belongs to the graph of y equal x squared minus 1. So technically, when x is equal x, any x on that graph, to calculate y, you plug in that x right here, right? This is how we calculate y. So y, it's technically x squared minus 1. So in those type of problems, you want to replace y with the equation, which is x squared minus 1, because we don't have that specific point. Okay, so P has coordinates x and y. Y coordinate has to satisfy has to satisfy the equation, which is x squared minus 1. So you're going to replace that y with x squared minus 1. Okay, so point P will be your x2, y2. Okay, from distance formula. So P is your x2, y2. Okay, so now we're going to find the distance. Next, find the distance between O, which is again 0, 0, that's the origin, and P, which is, why that pen gives me a hard time. P is your x, and y satisfy the equation, which we're going to replace y with x squared minus 1. Okay, so this is comes from the equation. So we're going to plug it in into the distance formula. So again, we have x1, we have y1, and we have x. From point P, it's your x2, and that's your y2. Okay, so let's use distance formula. D square root, let's rewrite that, x2 minus x1 to a second power plus y2 minus y1, just slower, okay, to a second power. Okay, so this is the distance formula between 2 points. So D has to be function of x. That's why we're trying to rewrite everything using only x values. x2 minus x1. So x2 is x. So we have x minus x1, which is 0, square, plus y2. So y2, it's x squared minus 1, x squared minus 1, x squared minus 1. So this is y2 minus y1 minus 0 to a second power. Let's simplify. So we're getting square root. X minus 0 is just x, so we have x squared plus x squared minus 1 to a second power. Okay, so what we just did, we just built distance formula using only x values, which means we actually built the function in terms of x. Okay. The only thing what I want you to do, let's just simplify that. Okay. So let's simplify. Let's evaluate that x squared minus 1 squared, which is the same as x squared minus 1 times x squared minus 1. Let's FOIL, and we're getting x squared times x squared, which is x to the 4 power. Okay, then you have x squared minus 1, which is negative x squared. Then we have negative 1 times x squared, which is negative x squared. And negative 1 times negative 1, which is positive 1. So let's simplify that, and we're getting here x to the 4 minus 2x squared plus 1. Okay, so I'm going back. Okay, don't forget that this is just x squared minus 1 squared. So let me just go back here. See if we can pick different color. Okay, and that will become, okay, square root. Okay, we still have that x squared, which I didn't touch, so we have x squared plus, from FOIL you have x to the 4 minus 2x squared plus 1. Okay, and that will give us x squared minus 2x squared. Let's combine it together. So we will have x to the 4 minus x squared plus 1. Okay, so d is a function, is expressed, let's just put it, is the distance. Come on, why you give me hard time? Is the distance expressed as a function of x. Of x. So d of x equal square root x squared, x to the 4 minus x squared plus 1. Okay, so we have it. Okay, now we can go back to part B. Let's see, that would be better. Part B. Okay, in part B, they asking you what is the distance, what is d, if x zero. Okay, so what is the distance when x is equal to 0? Okay, so technically what we're going to do, we have our distance formula right here, so we're going to replace x with 0. So d of 0 equal. Okay, square root 0 to the 4 power minus 0 to a second power plus 1. Okay, so we're just having square root of 1 which is equal 1. Okay, and let's solve C. What is D? If x equal 1. So you're going to do the same thing, substitute 1 for x. So d of 1 equal square root, and I'm going back to the distance formula, so we have 1 to the 4 power minus 1 to a second power plus 1. And that will give us square root 1 minus 1 plus 1, which is 1. Okay, so for C we also end up with 1. And the last part, D, what is D? If x is equal square root of 2 over 2. Okay, so the same idea, replace x with square root of 2 over 2. And this is what we're having. Okay, so here you have a little more calculations. We have square root of 2 over 2 to the 4 power. Okay, because don't forget that this is our formula, x to the 4 minus x squared plus 1. So minus x squared, so radical of 2 over 2 to a second power, and plus 1. Okay, and this is what we're getting. Radical of 2 to the 4 power, it's radical of 2 times radical of 2 times radical of 2 times radical of 2. So you're getting 2 times 2, which is 4, over 2 to the 4 power, 2 times 2, it's 4 times 2, it's 8, 8 times 2, we're having 16, minus 2 over 4 plus 1. Okay. Okay, and this is what we're getting. So 4 over 16, divide by 4, both of them. So you have a square root. We have 1 over 4 minus 2 over 4 plus 1. 1 I'm going to rewrite as 4 over 4. Okay, equal. So we're having 1 minus 2, negative 1 plus 4. We have 3 over 4 and everything is under square root. So this is the same as square root of 3 divided by 2 because radical 4 is 2. So that's the answer of part D, when you have to find the distance when x is equal to square root of 2 over 2. And next, I want to talk about E. Use the graph utility to graph the function. Again, so technically they asking you to graph, and all the time when they're saying use the graph utility, that means you should use the graphing calculators. I'm going to quickly show the graph, how that will look like. Okay, so you have to graph d of x equal square root x to the power of 4 minus x squared plus 1. Okay, so technically what you're graphing y, it's equal square root x to the 4 minus x squared plus 1. Okay, so I just quickly will show you how the graph will look like. Again, you won't have to do it on the test because I'm not going to ask you to use your graphing calculators for that. But the graph, hold on. Okay, the graph will look something like this. Okay, so they will ask you to graph the function square root of x to the 4 minus x squared plus 1, and they're going to ask you to round to 2 decimal places, find the values of x for which d has a local minimum. So they're asking you to find local minimum. Okay, so technically your local minimum, it's right here. Okay, this is the local minimum. And PowerPoint, if you guys will read the PowerPoint and you have calculator, just follow those steps because it shows you exactly how you can find that minimum, but your calculator won't find it, and the local minimum will be when x is equal 0.707 about. And the y value of that local minimum, okay, it's 0.87. I'm writing that 0.87. Okay, I'm going to put a star here because again, I'm not going to ask this one on a test. I'm going to stop the video, and in the second video of section 3.6, I will go over example 2 and example 3 from the PowerPoint. Okay, so thank you so much for watching. Stop recording.